So as we get into using our subprogram, I want to emphasize something about the name of the procedure that we created. We called it output user info. Notice the spelling of it. It doesn't use camel case like we do with our variables. So we might have a variable called like int user age. We notice the camel case. Every word after the first word has a capital first letter. In terms of naming our subprograms, we use something called mixed case, which means every single word starts with a capital letter. And this really only has one purpose: to differentiate our variables from our subprograms inside of our code. As we're reading through thousands and thousands of lines of code, we know at a glance which ones are actually subprograms and which ones are actually variables. Just the same way that we name constants with all capitals, again, to differentiate the difference between a variable and a constant at a glance. It's all about readability, making our code very simple to understand at a glance. So when we want to actually use our subprogram, the term we use is call. We're going to call output user info. We're going to call the subprogram, and we're going to give it the values for its parameters. Because right now, name and age, they don't even exist in memory. They don't have any values. We need to do all that. So all we have to do is the same way that we do it for variables. We just refer to it by name. So I might say output user info. Now if I just open and close my brackets with my semicolon, we see that immediately we get an error. Sorry, I can't do my job. I'm expecting a string and an int, but you gave me nothing. So we got to give it something. We got to give it that something in the proper order. So I must say, let's say Mr. Lane, who is 36, I guess. Now, if we display this, let's just quickly run this so you can see the result. We see name, Mr. Lane, age 36. It shows up on the screen exactly as we'd expect. Now let's see how this actually works. So what happens is, the program enters in the main, because all Java programs start in the main, and they start executing all the code inside the main, one line at a time. So it gets down to this output user info line, and then it literally jumps out, comes down here, and the first thing it does is it copies Mr. Lane into this new variable called name, copies 36 into this new variable called age. So these two variables now exist in memory, and they have values, Mr. Lane and age. And now it's safe to execute the code inside. It executes the first line, outputs name, executes the second line, outputs age, and then it gets down to this closing bracket. This is the end of this subprogram in all ways. So what happens is it jumps back to output user info. But as it's jumping back, it actually deletes all the variables and data that was created inside. So name and age are removed from memory. If we had another variable that we defined inside, a local variable, let's say string name2 for some reason, that too would be deleted from memory. So if I tried to do something like this, system.out.println name, it's actually going to complain to me saying that name doesn't exist. You see here, name cannot be resolved to a variable, because name doesn't exist out here. It only existed for that brief moment in time when output user info was actually executing, because as soon as it got to that closing bracket, it was removed from memory on a permanent basis. Oops, French keyboard options. So now let's try calling output user info again with some different data. Output user info, and we'll put Mr. Finley on here. I actually have no idea how old Mr. Finley is, so we're just going to say 32. It's probably highballing it a bit. But so we have Mr. Finley, Mr. Lane in this order. So Lane first, then Finley. So when we run our program, we can actually get rid of this variable now because it's not doing anything. We run our program, and we get Mr. Lane, age 36, space, because we have this space output here just for user-friendly purposes, and then Mr. Finley, age 32. Now, after it's done executing the first one, and then it outputs a print line, when it comes down in here, again, it will jump out, come down here, and immediately copy these variables, these values, directly into the variables. So Mr. Finley gets copied into name, and 32 gets copied into age. That's great. Now what if I wasn't using literal data? These are literal values, like actual numbers and strings. What if I wanted to use a variable? Let's say I had string username, which is equal to, I don't know, Johnny. And int user age is equal to 16. And instead of saying, well, let's do a third one, let's do a whole different one. We'll keep this, copy and paste. And instead of doing Mr. Finley and 32, we do username and user age. Now I want to emphasize a few things here. So first of all, when it gets down to this line and it tries to copy username into name, it doesn't copy the variable in there. It copies the value stored in username. So off in memory, let's go over to OneNote for a second. Off in memory, somewhere over here, we have, let me just put my pen on and some thickness. Okay. Now, if we were to draw our memory, it might look something like this. Now, in our memory, we have currently a variable called username. See if I can write this. And we have one called user age, and each one is taking up some memory. When we call output user info, it immediately creates this variable called name and another one called age. Now, currently in username, Johnny is stored, and age 16 is stored. When we call output user info, the value stored at username is copied down into name. So this also will hold Johnny. And age will also hold 16. But the original data hasn't changed. It's still there and it's in its own memory location. What this means is that inside that subprogram, if I change name, it's not going to affect username. Username has its own memory location. So let's just try that. Let's go over to our code for a second. And down in here, I'm going to say name is equal to Bart. And now when we go to output this, the third output of values should give us Bart and user age, which we didn't change, so it should still be 16. So we run our program and we get Bart 16. It didn't matter that we passed Johnny in because we just changed that value. That being said, if I try to out here, and here we change name, so we go back to our memory, we just changed Johnny here from Johnny to Bart. This username still holds Johnny. It hasn't been touched, which means back here, if I come down here and write system.out.println of username, I should still get Johnny. And I do. Because that variable location is its own memory location. It hasn't been modified in any way. This is a copy of the data. Copy of the value only. It is not the actual variable username. It's just a copy of what was stored in username. And I need to emphasize that because that is a very common mistake that a lot of students make. So make sure you realize that it's only a copy of the data. So also note that we can call this subprogram as many times as we want, depending on what values we put in there. And in fact, for these variables here, we could actually call other subprograms. I might have a subprogram, I don't end right here, but maybe I have a subprogram called getUsername. And that retrieves the username and puts it right here in the spot. It would do all this work first, and then it would do the output user info work. So if we were to draw the flow of our program at this point, in the past we've just had the straight top-down structure. Now what we've created is these idea of subprograms where we can kind of jump out of a location memory, jump over, then come back to the exact same spot we left off. And in fact, we can jump to that same subprogram from multiple points in our program. We can have multiple subprograms. We can have as many as we want. And maybe this one down here jumps over there and comes back up to here. The point is that it always comes back to the exact same spot that it left. It's never going to go back to a new one. So that is procedures. Next video, we're going to go on to functions.